Hello, I'm the Power Guy from TDK-Lambda. In this video, I'd like to explain why the temperatures of a power supply's key components should be measured and how best to do this. For our example, we are showing the TDK-Lambda CUS600M 600-watt AC-DC power supply. To ensure the system receives a stable output voltage for many years, it is important we know what temperature its components are operating at. This is done for two reasons. 1. It will ensure safety-critical parts are not exceeding the temperature limits stated in the safety reports. And 2. The performance of the heat-sensitive electrolytic capacitors will not degrade significantly during its life. Parts to be monitored are the power transformers, power devices, inductors, and capacitors. The electrolytic capacitors deteriorate faster as their temperature is increased. A rule of thumb is that for every 10 degrees C rise, their life halves. Therefore, a 20 degrees C temperature rise equates to a 75% reduction in its life. Without thermal measurements under actual operating conditions, the operating life is unknown. What happens when the capacitors start to deteriorate or even dry out? It is unlikely the power supply will fail and stop working. In normal life, we will have a stable voltage. Once the capacitors start to wear out, the output ripple will increase, and the output may begin to oscillate or whistle. If there is a load change, the power supply's response time will increase and could reset the system. The hold-up time will decrease, and the output could drop to zero during a very brief loss of AC power. The system may have an erratic start or restart, particularly at low temperatures. Never base your product selection on bench testing alone. To avoid optimistic readings, it must be performed inside the end system. The orientation of the power supply, the proximity of other heat-generating components, and any airflow restrictions may have a significant impact on thermal measurements and therefore its operating life. If a fan is being used to cool the power supply, air must be able to flow through the power supply and the hot air exit easily. If other system components severely restrict the airflow, cool air will not pass through the power supply and hot air will not exit correctly. This will raise component temperatures and could cause earlier than desired field failures. As mentioned earlier, the orientation of the power supply is important, particularly when the product is being convection cooled. No forced air is available. Heat rises and it can be seen on our vertically mounted unit. The hot air passes over the capacitors, increasing their temperature and reducing their life. The capacitors on the horizontally mounted unit remain cool. To accurately measure component temperatures and the ambient, use Type K thermocouples attached with adhesive. Ensure that the wires do not impede the cooling. Make sure the temperatures have stabilized. For convection-cooled power supplies, this can take up to 3 hours. Repeat the test at both low-line and high-line input voltages. Finally, using the measured ambient temperature, determine the power supply's life from the manufacturer's data. This is usually on their website, and you can ensure the temperatures of your power supply are acceptable. Reliability reports will give a basic indication of capacitor life with different load and ambient temperatures. Following these simple steps provides two benefits. 1. You can assess that your power supply actually does operate as stated by the manufacturer. And 2, you can be assured that thermally your choice of power supply will provide years of trouble-free operation. Knowledge is power. Power is TDK-Lambda. Thank you.